Hello everyone. This video will help you to understand how to solve problems in CDF for a discrete random variable. We will quickly recollect what is meant by a CDF. CDF, also called by the name cumulative distribution function, or called as distribution function. It is denoted by the script capital F of x and is defined as probability of all the values of x this are less than or equal to a current position called as x. So what do you mean by cumulant? Cumulant means add up all the data till a particular stage. So you will be adding the probabilities until a particular stage is arrived, or you add the total probabilities stage by stage for each of the point called as x. So in which case, for a discrete case, you add up all the probabilities p of xi, where my xi is going to be a value less than or equal to x. And for a continuous case, you integrate the function f of x dx between the range. What is going to be the lower limit? Lower limit is going to be minus infinity. And how about the upper limit? X less than or equal to x. So this x now plays the role of upper limit. So you will be integrating it till the position called as x. So for a discrete case, you add the probabilities till the stage xi, and for a continuous case, you integrate it till the point called as x. Next, a basic property of the cumulant is that the value of the cumulant always begins with 0. When you start adding, the prior probability begins with 0, and when you add up finally all the values, you will reach and end up at 1. This is because we know that when we add all the probabilities, the total sum of the probabilities is always equal to 1. So what happens? The total value of the cumulant always lies between 0 to 1. So let us keep this in mind. So we will move on to problems. Problem number 1. Let capital X be a discrete random variable with probability mass function defined as x takes the value 0, 1, 2, 3 and 4, and the corresponding probability of x is going to be 1 by 25, 3 by 25, 5 by 25, 7 by 25 and 9 by 25. The question is, find the cumulative distribution function of the random variable x. Now we have been given with the probabilities, and we know that this is going to be a discrete random variable. Our cumulant is going to be denoted by capital F of x. For a discrete random variable, estimation of a CDF is very easy. You will have to just add them up stage by stage. Keep in mind, if the first probability is not equal to 0, we know that f of x begins with 0. So what you do is just make a 0 prior to this first probability. So when we add this to the first stage, so 0 plus 1 by 25, at the stage x equal to 0, the cumulant will be 1 by 25. The next stage, when we move on, it is 1 by 25 plus 3 by 25 when it moves to stage 2. So it is 3 plus 1, 4 by 25. The next stage, when it moves to stage 2 and ends up at 2, you will have to add 4 plus 5. So that makes it as 9 by 25. The next stage, when you move, it is going to be, when you have arrived at 3, it is 9 plus 7. So that makes it as 16 by 25. The next stage, when you move, you add up the value. 16 plus 9 is 25 by 25, and we know that we have arrived at the value 1. So we see that we begin with 0 and always it ends up with 1. So if the first value is not 0 for the probability, just mark a 0 in front of it and start them adding up stage by stage. So this is how you calculate a CDF, or a cumulative distribution function, for a discrete random variable x. So let us move on with the second example. Problem number 2. If capital X is going to be a discrete random variable with probability function given by x varying as -2, -1, 0, 1, and the value of probability of x is 0.4, 0.1, 0.2 and 0.3. Find capital F of x. So how to find your capital F of x? Add them up stage by stage. So you know that this is not 0, so just begin priorly with a 0, and when you end up at the final stage, what your answer has to be? It has to be equal to 1. How to go about the process? Just add 0 plus 0.4, 0.4, 0.4 plus 0.1, 0.5, 0.5 plus 0.2, 0.7, and 0.7 plus 0.3 is 1.0. So we begin with 0 and we end up with 1, and we have arrived at our CDF. Isn't it so easy for us to compute the CDF of a discrete random variable, students? I hope you understood the concept behind it. Thank you.